Hi, and welcome to lab. Today we're going to be doing experiment 6, acid-base titrations. Titrating is very important to chemists and in the chem lab. Essentially, it's adding a titrant from a burette to a solid or liquid sample in another piece of equipment. And you'll determine the correct mole ratio of the two substances, and you're able to determine a great many things from that. Today, we'll first determine the molarity of sodium hydroxide using a primary standard, KHP, potassium hydrogen phthalate. Then we'll determine the percent acetic acid in an unknown solution. And finally, we'll determine the molar mass of a solid acid. The first step in our procedure, and I'd like you to follow along with me in your lab manual, is to normalize your burette with some of this sodium hydroxide solution. And in the second step, we need to obtain a mass of about 1.2 grams of KHP. Let's do that. I've normalized the burette and I've obtained the KHP, and you've recorded that. And in step 3, it says to transfer this KHP to the Erlenmeyer flask. All right, excellent. And it also says to add about 50 milliliters of water. Now, the amount of DI water we add is essentially unimportant. It's not going to change the titration at all because DI water does not contain any moles of acid or any moles of base, so there's nothing to neutralize. So the moles of acid from our KHP has not changed. And while I'm doing this, I'm just kind of targeting the walls when I'm adding this solution to get that KHP, any KHP that has been attached to the sides of the flask down into solution. There's about 50 milliliters of water. And we're going to swirl it a little. We're also going to add some phenolphthalein. Now, phenolphthalein is an indicator, and when our equivalence point has been reached, our moles of our acid are equal to our moles of our base, you'll see a pink color appear. And usually I'll add 2 to 3 drops. You also don't want to add too much of this. Phenolphthalein itself is an acid, and we don't want to add extra sodium hydroxide. While I'm mixing this, why don't you read the initial burette reading of the sodium hydroxide solution that we're standardizing. Okay, we're ready to start titrating. Now, all of our solid is not dissolved yet. That's okay. Once we start titrating, it will go into solution, and we'll also see that there are some particles of KHP on the sides of our flask since we've been swirling. We'll get everything in solution, and then we'll use the DI water bottle to wash that down. So right now, I'll probably add about 1 milliliter at a time, or just just dripping. You don't want to go too fast. Initially you can. And you might be able to see a little bit of color right at the point where it's being added. Again, it's okay that that solid is not all dissolved. It will be. And I'll add it. You can see the color pink and it will fade away. Our solid is starting to dissolve completely now. Just got very little of it left. And I'm just going to put this on a slow drip, constantly swirling. I still got a ways to go, I think, before I start making even smaller increments. And always, if you're going to remove the Erlenmeyer flask from underneath the tip, always be sure to touch the tip of the burette, which usually contains a drop of your titrant, to the inside wall of the flask. At this point in time, I'm going to wash down any of that KHP that has been stuck to the sides of the flask. Give it a swirl, and you can see all of our KHP is now dissolved. And I am just going to add at slower increments, just drop-wise, and getting ready to turn this off at any minute. I can tell I'm getting a little bit closer to the equivalence point because it's taking longer for the pink color to disappear. I'm going to stop for a minute. Sometimes it's helpful to put a piece of white paper underneath to see the color. It's still clear. We still have a little bit more to go. I can tell I'm very close. So I'm just going to add it maybe drop-wise at this point in time. And there is our titration complete. You can see the pink color. I'm going to rinse down the sides of the flask, and that is a beautiful titration. I'd like you to read the final burette reading of the sodium hydroxide solution. Now we need to make a second determination and make sure that both molarities that we've calculated are within 5% of each other. But before we make that second determination, we need to check the level of sodium hydroxide in our burette. And it's about 25. And I needed at least that, or about that, for the first determination. So it's always a good idea to check that and then add some more, which I'm going to do. You never want to run out. And that should be plenty for our second determination. I'd like you to read this burette reading and weigh another about 1.2 grams of KHP. Okay, now for our second determination, again, we're going to transfer the KHP to the Erlenmeyer flask, add some DI water, about 50 milliliters. Again, the amount is not important. And a couple drops of phenolphthalein, the indicator. Give it a swirl to mix everything, and we can start our titration. Now, we've obtained a similar amount, it doesn't have to be the exact amount, doesn't matter, of KHP, and our last titration took about between 24 and 25 milliliters. So I can easily add about that same amount and back it off a milliliter too. This is about, I'll just round it up to 16.5. And if I add maybe 20 milliliters to this right away, which we can do, I know I will not have overshot that equivalence point. And then we can go drop by drop after that. All right, so why don't I drain about 20 milliliters from my burette right away. And I know I will not overshoot my equivalence point here. Okay, there's about 20. The pink will go away. And I'm going to touch the inside, the tip of the burette to the inside of the flask. I'm just going to swirl, making sure that all my KHP is dissolved. Bring it over the black lab bench top to look at that. It's not completely dissolved yet. And I also need to wash down the sides of my flask from any KHP that has been swirled up there. Still have a few grains that need to dissolve. I can go drop by drop, and I'm quite sure those will go away. It's a good rate. And it looks like the pink color is taking longer and longer to go away. I'll have my other hand on the stopcock to quickly shut that off. I'm going to stop that. Touch the inside tip, and there is another beautiful titration. I'd like you to read the final burette reading. In the next step of the procedure, we'll determine the percent acetic acid in this acetic acid unknown. And I've rinsed both of my flasks, once with tap water and once with deionized water. So first we'll lift up on the barrel of the auto dispenser. And if there's a drop that comes off, you can just touch it to the inside of the waste beaker. And then we'll put our Erlenmeyer flask underneath and gently press down on the barrel, touching the drop to the inside. And we have 10.0 milliliters of our acetic acid unknown dispensed to this flask. I've refilled the burette with the sodium hydroxide solution that we just standardized, and I'd like you to read the new burette reading for this part. Okay, in step 3 of this part, it says to add about 25 milliliters of DI water. Again, we're not adding any acid, we're not adding any base, so it doesn't really make any difference how much we've added. We're just getting the volume up a little bit just so we can see the color throughout. And we've done that. And I'll add our indicator, phenolphthalein. And I will start titrating as before. I'll go quite a bit faster in the beginning, although this time I don't know how much our target should be. Maybe I'll just add another milliliter or two before I go dropwise. Okay. I'm going to touch the tip to the inside of the flask because I'm going to remove the flask. And just in case anything got attached to the sides of the walls, inside of the walls, we'll get that down. All right, now I can go dropwise until my equivalence point is reached. I'm going to put my other hand kind of on the stopcock, ready to shut it off the moment the solution turns pink. Still looks like we're pretty far away from the equivalence point though. And again, the equivalence point is when the moles of the acid are equal to the moles of the base. It appears that it's taking a little bit longer for that pink to go away. So hopefully I'm going to be closer to my equivalence point. Not done yet. I turned it off, thought I was almost done. Our second titration will go very quickly, I will hope. We should be only a few drops away now. And I think I over-titrated that. But this will give us at least a good idea. Over-titration, by the way, is when you add too much of your titrant. I think I added probably an extra 4 or 5 drops over than what I should have. It's very easy to do, but even a half a drop can make it go even darker pink than that. Now let's do the second determination. I've already refilled the burette with sodium hydroxide solution, and I'd like you to read it. I've also obtained another 10 milliliters of our acetic acid unknown, and I added DI water and phenolphthalein, and we can titrate as before. Again, since this is the second determination, and I know it's almost essentially the same amount of acetic acid that we've added, I'm just going to drain about, 25 or so milliliters right off the bat, and then I can go drop-wise. I'll touch the tip to the inside of the Erlenmeyer flask and wash down the walls again. And now I'll go drop by drop. I'll pull this down so you can see how slowly I'm going. And constant swirling just ensures that everything is mixed well. Again, it looks like it's taking a lot longer for the pink to disappear, so I know I'm getting closer to the equivalence point. Stop for a minute there. I'm actually going to check. One more drop might do it. And that is a beautiful titration. I'd like you to read the final burette reading, and then you can complete the calculations for this section. In the last part of our procedure, we'll determine the molar mass of an unknown solid. I'll refill the burette with the sodium hydroxide solution, and then could you please weigh about between 0.4 and 0.5 grams of this solid unknown acid, and let's make a note that it's a diprotic acid. That will be very instrumental in our calculations. All right, now I'll add the solid to our Erlenmeyer flask, and this is an Erlenmeyer flask that I've rinsed with tap water and then DI water. I'll add about 50 milliliters of DI water to it, trying to target some of that solid that is on the walls, putting it back into the bottom of the flask. And then I'll add about 2 drops of phenolphthalein. Now, many of these unknown solids have a hard time getting into solution. They're all organic solids. And so sometimes it'll just take a little while to get those into solution. We'll add some sodium hydroxide. We can add it in a long stream at first. And then at some point we'll stop and make sure that we've got all of the solid off of the walls of the Erlenmeyer flask. Stop maybe here. Again, touch the tip of the burette to the inside of the flask. And it looks like all of our solid is in solution. Rinse down the walls. And at this point in time, I can maybe a faster drop. I don't know whether you're able to see that. Just for a little while, and then I'll slow the rate down again. When it looks like the pink color is taking longer and longer to go away, and it looks like we have reached the equivalence point. Touch the burette tip to the inside of the flask and just rinse down the walls. The sodium hydroxide or solid that is on the sides of the walls. And let's read our burette. Now that we're done with our experiment, we just need to clean up. We'll drain our burette and we'll clean all our equipment, kind of rinse it with DI water and put it in the center for the next group. When our burette is done draining, we'll refill it with DI water and flip it with the stopcock open, signaling a clean burette. Thanks for being my lab partner today.